Right now, astronauts on the International Space Station don't do laundry. They wear the same outfit for days, sometimes a full week, and when those clothes get too dirty, they are packed into disposable cargo ships and launched to burn up in Earth's atmosphere. Sending a traditional washing machine to space is out of the question. Without gravity to hold liquid down, an agitation cycle would just create a chaotic suspension of soapy water in clothes, making it impossible to properly rinse or drain the fabrics. And if any of that water escapes the machine, it becomes a severe hazard. Floating droplets can easily drift behind bulkheads, short-circuiting vital electronics, or hiding in dark crevices to breed aggressive, unchecked mold. Burning dirty clothes only works because the station relies on a continuous chain of resupply rockets from Earth bringing fresh garments. It's a logistical luxury that disappears the moment we leave low Earth orbit. Consider a 3-year round-trip mission to Mars. There are no resupply ships out there. The crew is entirely cut off from Earth's manufacturing base. If astronauts have to pack enough replacement underwear and coveralls to last thousands of days, they have to bring hundreds of pounds of extra cargo. In aerospace engineering, mass is the ultimate enemy. Every extra pound of payload requires exponentially more fuel just to lift it out of Earth's gravitational pull, consuming critical space that should be reserved for oxygen or scientific gear. But wearing the same untreated garments for months isn't an option either. Common skin microbes like Staphylococcus multiply rapidly on sweat-soaked synthetic and cotton fibers, creating odors and potentially spreading infections in a highly enclosed environment. For deep space travel, the inability to wash clothes represents a heavy mass penalty and a direct biological threat to planetary protection protocols. We have to find a way to clean fabric without water. The solution to this logistical trap involves skipping liquid entirely and utilizing the fourth state of matter, plasma. If you take a gas and inject it with enough electrical energy, the gas becomes electrically energized. It transitions into a stream of highly reactive ions and electrons. Normally, we associate plasma with the superheated surface of the sun, but by mixing electricity with specific trace gases like helium and ambient air, researchers can generate cold atmospheric plasma. This creates a room-temperature, bright purple jet of charged gas that is entirely safe to touch. By replacing heavy, sloshing liquid solvents with lightweight electrical and gaseous reactions, astronauts can sanitize their gear using resources they already have on board. When this purple plasma jet makes physical contact with a dirty textile, it initiates a microscopic process called oxidative stress. The electrical energy from the plasma interacts with the surrounding air to generate highly reactive oxygen and nitrogen species, such as ozone. This charged gas penetrates deep into the fabric fibers without making them wet. These newly formed reactive molecules are highly unstable, and they violently steal electrons from any bacteria they encounter. This molecular theft physically ruptures the protective cell membranes of the microbes, destroying them on contact. This chart displays the survival rates of common microbes on fabrics treated with cold plasma. The steep downward trajectory of these plot lines shows a rapid reduction and complete inactivation of hardy bacteria like E. coli and Bacillus within just a few minutes of exposure. While the bacteria are ripped apart, the structural integrity of the cotton and synthetic fibers remains completely undamaged, meaning the same garment can be treated and worn over and over again. A plasma gun won't lift a coffee stain out of your shirt, but it perfectly eradicates the microscopic threats that cause odors and disease, neutralizing the true biological hazard to the crew. This closed-loop, electricity-powered cleaning system is already escaping the lab and entering the commercial market here on Earth. The traditional textile industry is one of the most resource-intensive sectors on the planet, relying on billions of gallons of water and a massive array of toxic chemicals to produce and treat fabrics. Now, consumer products are adopting this space-derived technology. Handheld devices are already available that use cold plasma to dissolve odor molecules out of everyday clothes, freshening them up without requiring a full wash cycle. At the industrial scale, factories are beginning to use cold plasma to engineer water-repellent and antimicrobial fabrics, achieving these chemical coatings using only electricity and gas, completely bypassing the creation of toxic wastewater. By trying to survive the extreme weight and resource constraints of deep space, engineers accidentally accelerated a zero-waste technology capable of cleaning up one of Earth's dirtiest legacy industries. As the Artemis missions prepare to launch the first components of permanent lunar and Martian habitats, the math of space travel comes into focus. Sustaining human life permanently off-world requires us to look at every mundane Earth convenience, even doing the laundry, and completely rebuild it as a strict, closed-loop resource system. Cold plasma technology bypasses the severe mass penalty of carrying extra clothes and circumvents the absolute lack of flowing water in zero-gravity environments. Mastering microscopic chemical reactions, learning how to pop a single bacteria cell with an electrified gas, is a mandatory requirement for humanity's expansion across the solar system.